Okay, so on this worksheet, we're going to leave everything in simplest radical form. Which means if your answer has a square root, leave it as a square root, but you got to simplify it. The 30, 60, 90s, 45, 45s, those are easy to do. So remember on the 45, 45, both legs are the same. And the hypotenuse is simply whatever the leg is times the square root of 2. So there won't be any simplifying on these. If to find the leg, if you know the hypotenuse, it's half of the hypotenuse times the square root of 2. Okay? Now, if they gave us one, we haven't had one like this, but you will see them. Say the leg is 3 square roots of 2. Obviously, x is also 3 square roots of 2 because the legs are the same. And then in order to find y, the formula is you got to take the leg times the square root of 2. Yep.
Question, wouldn't it just be 6 because then the square roots would cancel out? Is that a reasonable line of thinking?
It is reasonable, but you're off just a hair.
Okay.
Because when you do this, what is the square root of 2 times the square root of 2?
Square root of 4.
Which is
2.
2. So it's just 3 times 2, which is 6. That's what you got, right? Yep. So remember, when you take a square root times a square root, if it's the same number, the square roots just cancel each other out. So leaving them in simplest radical form here is easy because it comes simplified right away. The 30, 60, 90 you have the hypotenuse, and then there's a short leg and a long leg. So the easiest one is if they give you the short leg. The hypotenuse is just double the short leg. So this would be 6. The long leg is whatever the short leg is times the square root of 3. This one uses the square root of 2. The 30, 60, 90 uses the square root of 3. So then this would have to be 3 square roots of 3. Whatever short leg is times square root of 3. So then if it goes backwards, if they give you the hypotenuse, then the short leg is half of this, half of the hypotenuse times the square root of 3. Or, I mean, not times, that's long. Which makes it 5. And then the long leg then would be 5 square roots of 3. Then the one that's the toughest to remember is if they give you the long leg right away. This last one is the hardest to remember. It's basically the same as this, except square root of 3 and 3 1/3. So the short leg is the long leg times the square root of 3 divided by 3. It really is the same because you could write this as the hypotenuse times the square root of 2 divided by 2 instead of saying 1/2. So they're the same thing except with 3 in it instead of 2. So this would be 10 square roots of 3 divided by 3. You can reduce it if it will reduce, but 10 over 3 won't reduce. But remember, you can't cancel anything out with numbers inside a radical with numbers outside. And then sometimes people have trouble with this. you double it to get this. The only number you double is that one. It's 20 square roots of 3 over 3. Okay? So on the worksheet, they got these mixed together with some Pythagorean theorem, which I'm just going to do a couple to remind you. You use the Pythagorean theorem, and again, all of this is right triangle stuff, if you know two sides. The special triangles, you only know one side. So, if you know two sides, you can find the third by doing a squared plus b squared equals c squared. Now, remember the shortcut? Or it's just this squared plus this squared, and then you square root it. And then the other type is if you know the hypotenuse, and you're looking for a leg, it'd be this squared minus this squared, and then you square root it. Remember, you subtract them when you know the hypotenuse, you add them when you know. Ever remember that? I see some blank stares. So, this would just be 8 squared plus 3 squared square rooted. Now, the difference with these is now on this one, we got to leave it in simplest radical form. When we did these before, we just punched them in, rounded to the nearest tenth. So 8 squared plus 3 squared is 73. Will that simplify? No. Remember, it's if the perfect squares go into it, square root of 4, square root of 9, and so on. If any of these numbers go into here, it's not simplified. But nothing will happen there, so you just leave it square root of 73. Because no perfect squares go into 73. Here, when we do this, we'd have to subtract, so it'd be 20 squared minus 8 squared. And that's square root of 336. That one will simplify. If you just want to start with one you know, I know 16 goes into it. Well, I guess I didn't know that, but you could guess. Let's start, I know 4 goes into it. 4 times 84. So that would simplify to 2 square roots of 84. But now 84 is not simplified. 4 goes into it again. This would turn to square root of 4 times the square root of 21, which is 2 square roots of 21. So we still have this 2 here, that 2, and the square root of 21 would be 4 square roots of 21. If we would have noticed the first number that I said right away, 16 is the biggest square that goes into it, then we would have got it right away. Okay? So, that's all the worksheet is the special triangles and the Pythagorean theorems. And then you just got to leave them in radical form instead of decimal.